Two of the most powerful triangle formulas, the sine rule and the cosine rule, both fall out of one simple move, dropping a single height inside any triangle. Take any triangle with sides A, B, and C and angles A, B, and C opposite them. From vertex C, drop a perpendicular height, h, straight down to the opposite side, C, splitting that side into two pieces, x and C minus x. This creates two right triangles glued back to back. From the first triangle we get b squared equals h squared plus x squared, and from the second we get a squared equals h squared plus, open bracket, c minus x, close bracket, squared. Looking at the first right triangle, the segment x is just b times cosine c, since x is the side adjacent to angle c in that triangle. Now substitute x equals b cosine c into the second equation and expand it out. A squared equals h squared plus c squared minus 2 cx plus x squared. Group the h squared plus x squared together, and notice that is exactly b squared from the first equation. So a squared equals b squared plus c squared minus 2 cx, and substituting x equals b cosine c gives a squared equals b squared plus c squared minus 2 bc cosine c. That is the law of cosines, essentially Pythagoras, with a correction term for triangles that are not right-angled. Now let's get the sine rule from the very same two right triangles, but this time we focus on the height itself rather than the base. In the first right triangle, h equals b times sine a. In the second right triangle, h equals a times sine b. Since both expressions equal the same height, we can set them equal to each other, as sine b equals b sine a. Dividing both sides by sine, a times sine b, rearranges this into a over sine a equals b over sine b. By symmetry, if you had instead dropped the perpendicular from a different vertex, the exact same argument would bring side C and angle C into the pattern, giving a over sine A equals B over sine B equals C over sine C, the sine rule. So one height drawn once inside a triangle and viewed two different ways gives you both the sine rule and the cosine rule. Like and follow for more math tutorials, one idea at a time, nothing rushed.